Welcome to Unit 3, Lesson 6. I hope you have your coffee ready because we are about to do some mathing, some serious calculationing. Okay, let's look at this title screen here. Looks very complicated. Phase shifts, translating sine and cosine functions. Okay, all functions in the sine and cosine family of functions can be completely described by their amplitude, period, vertical shift, and horizontal shift, which we call phase shift. And then we got this crazy little photo right here, this picture rather, and it seems complicated, but you know what? The doing, the doing of this and the learning how to do this is what you better understand. You don't have to understand this picture right from the get-go. But at the end of the lesson, if you come back and look at this, you should have a better understanding of it. In fact, by the time we get done with this, you should have a better understanding about this content than you did before you started this video. That's the whole purpose of it. That's what teaching does. That's what learning is, okay? And even if you don't get it down after watching this video once, go back to the parts that you were a little confused on and rewatch them. Okay, and what we're going to do is we're going to apply some things that we've learned before about graphs moving left, right, up, and down, and we're just going to apply them to sine and cosine because we just learned those graphs. It's pretty much that simple, okay? So let's go ahead and get started. All right, let's think about some prior knowledge that we learned either earlier this year or even before that. Okay, let's look at this first thing here. Let's recall the parent function, all right? Y equals x squared. I hope you know at this point, that is a graph of y equals x squared. It is a perfect parabola. Love it. It is the basis of everything we start to learn when it comes to quadratics and graphs for quadratics, okay? Now, the next question, or the first question after that statement, is how is the graph of y equals x squared plus 5 moved? Meaning, if I look at my original graph, x squared, all right, what does this plus 5 do to the movement of that? Well, we should remember that if I add something outside of parentheses, okay, which that is clearly added outside of the squaring function. Remember, this is a quadratic because we're squaring something, okay? If I add something outside of the square, which I am, that tells me I'm either moving it up or down. It's a vertical movement. It's like our midline when we graphed sine and cosine. You know how we like always added something at the end and that was our new midline? Because the whole graph either moved up or moved down. Same thing applies here, all right? If I add 5, technically, I'm going to move this thing up 1, let me see, 2, 3, 4, I mean, probably about there. And that's what our next graph is. That's the graph of x squared plus 5. Very good, very good, very good. Let's get rid of that. Now, let's take a look at our next question. How is the graph of y equals x minus 4 squared plus 5? Okay, well, I'm still going to, okay, if I look at my plus 5, that was a premature toss. I shouldn't have tossed that parabola just so carelessly and violently across the screen. But I'm still going to take my x squared and move it up 5. So my x squared is still going to move up 5, right? But what about when we square, or excuse me, we add or subtract inside our square? Well, it works the opposite way, okay? I don't want to move left 4 because we always think on the x-axis the negatives go to the left. But inside parentheses, it always behaves in the opposite fashion. This is going to move right 4, okay? The 5 tells me I move up 5, and the minus 4 in the parentheses tells me I'm going to move right 4. So not only am I going to move up 5 from the original and end up with what I have right here, but then from there, okay, let me do this. I'm going to move right 4. I don't know, maybe somewhere like that. And that's exactly where our next parabola is, okay? So if I look at x squared, I'm going to move up 5 and right 4. And that is exactly where I am. And this is something we learned. I think it might have even been in Unit 1 with quadratics. I can't even remember at this point. Go, get, move. You, I want to stay. Yeah, that's good. As good as I can get. All right? So the key question is, now that we learned how to graph sine and cosine, okay, how do these apply to sine and cosine? They apply to them in the same exact way. So you'll see the statement at the bottom. We will use the same rules when shifting trig graphs. It's shifting. We are shifting it left or right. We are moving it up or down. Okay. So my sine graph. Okay. Let's say I had a sine graph here. That's sine the s, right? Maybe it will move up 5, then over 4. That's it. It's the same rules, okay? And today we're going to explore sine and cosine graphs and how they shift. Same exact rules, all right? So don't be intimidated. Move this back down here. All right, so let's look at some things here, okay? Transformed functions are of the form y equals a sine, in parentheses is bx minus c plus d. Or we could say cosine instead of sine, okay? Because we can shift the S curve for sine or that cup for cosine, all right? And let's just do a quick little review. And most of this, we should already know. My A, that's still amplitude. Let's not forget, if it's negative, it's a vertical flip, right? A, the number without the plus or minus, is my amplitude. Okay, if you want to consider it, okay, the absolute value of A, whatever, because we don't care about the plus or minus for amplitude. The minus only tells us we're going to flip it. So instead of having an S like this for sine, if it's negative, it goes down, then up. Okay, we flip that vertically. All right? All right, so that's our amplitude. Now, well, let's do another color here. Highlighter. This D, that is still our midline. That represents our vertical shift, right? That's how far up and down the graph moves. That's where the middle of my graph starts. So if I am adding nothing here, if there's 0 there, my S should stay right there. But if that becomes like, say, a +4, then my whole midline, the middle of my graph, moves up to 4. And that represents the vertical shift up or down, okay? So we know that. We're good with that already. All right, so let's take a look at something else. Green. I like green. It's a good color. B. B is still my frequency. I am still going to need that to find out my period, okay? The only difference, and I'm kind of getting ahead of myself. If B is the frequency, let's not forget period equals 360 over your frequency. And I want to use F instead of B. Or if it's in radians, we could say 2 pi over frequency, okay? And let's not forget that I can just move P and F. If I have the period, I can switch P and F. I can say F equals 360 over P. So if I knew the period but not the frequency, I could just switch those and find the frequency. Same thing, or if it's in radians, we say 2 pi over the period. Okay, so that's all good. We know this. We've been doing this for 2 lessons now when we graph sine and cosine. The one thing that is different, highlighter, purple, is this bad boy right there, the C. Now remember, if we are adding or subtracting inside parentheses, just like the parabola we did. Remember we had x minus 4 squared? That tells us whether we move left or right. But it's like opposite movement. Minus moves to the right. I'm subtracting the C, so I'd move to the right C units. Or if I was adding C, okay, if that was a plus C, I would move to the left that many units, okay? So C is the movement of the graph left or right. However, it's negative C divided by B. Now, there are 2 ways to do this. This is just for those people that say, I just want to know how to do it. Bam, there it is, okay? I like to factor out my frequency, okay? But ultimately, you would get the same thing that we have down here. So, what are we saying? Okay? If I want to know how far left or right that's going to move, it's not just the C. You got to take your C and divide it by B. Okay? In this case, they do negation because it's the opposite. You want to flip your C, so you leave that negative. Okay? So that is going to be really what tells you left or right. Now, that may be confusing right now. But let me explain just something now. And then we're actually going to do one And then hopefully you make the connection, because you're not going to have A, B, C, D. You're actually going to have numbers, and we're going to actually show those movements, and you can make that connection. But first, let me give you a brief reason why or how come it is like this. My frequency should not have any effect on my movement left or right. So for example, if I have the sine of 3x minus, let's call it 60, and this is in degrees. This is not radians, this is degrees. Right now I'm, excuse me, wow, where the hell did that come? Right now, the 60, no, but seriously, let me take a sip of this coffee. Man, not only does that help clear the throat and the sinuses, the caffeine just jacks me up. Now, here we go. You ready? Right now you're saying, okay, minus, it's opposite. So I move to the right, not the left, 60 degrees. I do not move to the right 60 degrees. But Visca, you said my frequency should not have any effect. This is frequency. That's the B, or I will call it F. You can call it B if you will. Okay. That should not have any effect on it. So I'm going to factor out this 3. Okay? So now I have the sine. I have 3 times, okay, if I divide this side by 3, it's an x. Minus, if I divide this 60 by 3, I now get 20. Okay? So now, I don't move to the right 60, I am moving to the right 20. Okay? I'm moving to the right 20. All right? So this frequency I have to take out of the parentheses, because the frequency, if I distribute my 3 back in, that's how I get 60. But my movement left or right shouldn't have the 3 in it. That's why I need to factor it out. Now, we should all be really good at factoring. Okay? And now, you might say to yourself, well, Visca, where does this come from? This was initially my C. Let me clean this up. This was initially my C. And this, I like to call it B. Or I like to call it F, but we'll call it B. Okay? What did I do when I factored out my 3? Didn't I take my C and divide it by whatever my frequency was? That's why they say, hey, just memorize that. You don't have to factor it out. You could just memorize C divided by B, because I had to take my 60 and divide it by 3 to factor out the 3. And that's exactly what this is right here. Okay? This looks sloppy. This looks messy. And I took a lot more time to explain this than I'd like to. But it's important. If you're like, I kind of get it, all right, well, let's start doing some of these and actually applying it, because that's where it's really going to drive home the theme and the theory and the purpose here, okay? Phase shifts and vertical translations do not change the period or the amplitude, okay? However, the length of one cycle, in this case, it's cosine, okay? The length of one of those C curves, that cup, will not change by moving it up or down, left or right. All right, just know that, okay? So let's look at example 1. Graph one cycle of y equals cosine of 3x minus pi plus 7. All right, I'm still going to write like my little amplitude, my little frequency off to the side, figure out my period, my midline. I'm going to do all that still, just like we're graphing sine or cosine, without moving it left or right, without a phase shift. Okay, I'm going to do that right now. So, before I do that, I get in the habit of rewriting this equation after I factor out my frequency. Because right now, this is telling me, oh, look, I move up 7, and I'm moving to the right pi, or that's the same thing as 180 degrees, okay? I do not move right 180 degrees or pi. If you just remember this formula, I take, this is my C and this is my B, right? I'm going to take pi, it's already minus pi, right? If I want to negate it, over B, which is 3, haha. So that would be pi over 3, which is, that's 180. So I'm really not moving right 180. I'm moving right 60. Okay? So you can do it that way. Or you can just factor out the 3. I prefer to factor out the 3 because you guys really need to be good at factoring. All right? And when I factor out my 3, I'm still going to get this. I'm still going to divide negative pi by 3. And what do I mean? This is how I do it. Okay? You can do it this way. That's fine. I say y equals the cosine. I take out my 3. When I take out my 3, I got to divide this by 3. So now I just have an x, and I divide this by 3. Look it. That's my negative pi divided by 3. Okay? So I want to make this into degrees. I hate the fact that it's radians. I want to make it degrees. So it's 180 divided by 3, which is 60. So it's minus 60 now. I still have my plus 7. I still have my plus 7. This right here is now my brand new stinking equation. I don't want the crayon, I want the highlighter. I'm graphing this. I'm getting all my information from this right here. Okay, this is what I'm going to graph. Okay, let me erase this negative c over b. All right. Now, my amplitude, it's still 1. This is a 1 in front, so it's 1. Okay, I'm graphing cosine, so I know it's the cup. I always like to draw. Now that I have sine and cosine, I have the S and the cup, I always like to write a little visual of what I'm graphing. So when I get time to graph it, I know which one I'm graphing. Okay, my frequency, okay, this is my amplitude. That's my frequency now. It's out here by itself. 3. My period, it's 360 divided by 3. That would be 120 degrees. Okay, my midline, it's plus 7. They call that D. I like to call it M. I like to just call amplitude A, frequency F, and midline M. Okay, so that's what I'm going to do. Gosh dang it, I do what I want. Okay, so that now, instead of being y equals 0, it's going to be y equals at positive 7. That's where our midline is going to be. And my amplitude is going to go up 1 from that and down 1 from that midline. Right? Now we have a phase shift. Remember, this behaves in the opposite manner. So I'm not moving left 60, I'm moving right 60 degrees. Okay, so the shift means I'm moving, and I'll just do an arrow, it's right 60 degrees, and this really tells me I'm moving up 7. Okay, now some people like to sketch this first, and I don't blame them, because when you make your final answer drawing, you want it to be precise. Some people are good at doing this, some people aren't. We're going to pretend that we're learning this for the first time, which most of us are. Okay, so forget about this movement right here. Okay, if I were to graph it without this movement, here is 7. This is where I'm starting. My amplitude tells me to go up 1 and down 1. So I go to 6 and to 8. Okay, it's the cosine cup. And right now, it goes out 120 degrees. Half of that's 60. Half of that's 30. Here's 0. 30 and 60 give me my 3/4, 90. If I graph cosine, it starts up high, and it ends up high. In the middle, it's down low. And in between those high points is where it hits my midline, 7. And I do the nice little curve. That's a little sketch before any movement left or right. Now, if I'm moving this right 60 degrees, now I'm going to apply this. If I'm moving right 60 degrees, I need to add 60 degrees to every degree I have on my x-axis here. So instead of starting at 0, I add 60, and that's going to become 60. My next dot isn't going to be at 30. I need to add 60 to it and make it 90. I add 60 to 60, it's 120. I add 60 to 90, it's 150. And I add 60 to 120, that makes it 180. So my graph isn't going to go from 0 to 120. It's actually going to go from 60 to 180. So to do that on the side first before you actually draw your final answer, to me it's valuable because my final answer, I want it to be pristine. I want it to be nice. I want to have some sort of rough sketch and then wow you with how good I am at this stuff. So now let's give our final little answer here. All right. And again, when you get good at this and you can do these numbers in your head, can you maybe skip this step? Yes. But when people skip this step and they try and calculate and move and they're like, oh my God, it's trigonometry and now I got to move it, they get nervous and they make mistakes. Okay. One day you'll get so good at this, you won't make mistakes and you won't have to do these little minor sketches. I like to see a roadmap before I go. Bang, bang. Here's 7. Here's 6. Here's 8. All right. Now keep in mind, I am starting at 60 degrees now. So what am I going to do? I'm not going to start at 0. My first thing is going to be at 60 degrees. My next one, it's going to be at 90. After that, 120. Then we have 150. Then we have 180. Okay. So I draw my dots. This coordinate right here is going to be at 60 degrees at 8. So I'm not going to put it right here. That's a no-no anymore. It's not starting at 0. It's starting at 60. So I'm going to put it right here above 60. And then it's going to end at 180, up high at 8. Then 120 is my middle. That's my low point. And then at 90 and 150 is the midline. Okay. So I have this curve that looks something like that. Now that's perfect. So let's take a look at how this actually moved. All right. First of all, before I had any movement left, right, or up or down, it probably went right there, 120 degrees. It's a little bit past 120. Excuse my sketch. It's not, whatever. But then I moved up 7. My midline went up to 7. Boom. And then I moved to the right 60 degrees. Boom. And that's all we're doing, up and over, down and over. That's it. Okay. Let's try another one. Graph one cycle of negative 5 sine of 2x plus pi over 2 plus 1. Right away. I know this is 90 degrees. Boom. So I'm going to make this 90 to make it easier for myself. All right. Now I'm going to factor out my frequency. So really I want to say y equals negative 5 sine. I'm going to take out the 2. Okay. Which means if I divide this by 2, I get x. If I divide 90 by 2, I get 45. So it's plus 45. And I still have my plus 1. Let's do the amplitude, the frequency, the period, and any of our shifts, up or down, left or right. My amplitude is 5. It's negative, so it's a vertical flip. If you want to put VF for vertical flip. So instead of starting up and down my S is going to start down, then up. Again, I'm going to sketch that so I know that's what I should be drawing. Okay. My frequency is 2. Thank you very much, Mr. Factoring. And my period is 360 divided by my frequency, which is 2. It's 180. Okay? My midline, I'm moving up to 1. So instead of y equals 0, which is the x-axis, it's y equals 1. And now, which way am I moving? If I'm adding 45, I'm not going to go to the right. It's the opposite in parentheses. I'm going to go to the left 45 degrees. So I'm moving left 45 degrees. All right? So, I don't know, let me do a little sketch of this thing right here. And then I'm going to, okay, my midline is at 1, so I'm going to put, there's 1. I'm going to go up 5 and down 5, so I'm going to go up to 6. I go down 5. That will be to negative 4. This isn't to scale, but it's just, all right. And then my S is going to vertically flip. It should go 180 degrees. Right here, 180. Half of that's 90. Half of that is 45. I start at 0. That's a 5. 45 and 90, that's 135. Okay. And before moving anything left or right, it's my S. Starts at the midline, ends at the midline, and the middle is the midline. Okay? Because it's flipped, I'm not going to start going up. I'm going to go down to -4 first, then up to 6. So my S is really going to look like that. The only thing I got to worry about now is my phase shift. I am moving left 45 degrees, which means all those angles that I have written on the x-axis, I need to subtract 45 from them. So I have 0. Don't forget, this is at 0. If I subtract 45, I'm going to be at -45. This was 45. If I subtract 45 from that, that's at 0, and so forth. 90 minus 45 is 45. 135 minus 45 is 90. And 180 minus 45 is 135. So look, I'm going to start in the negatives, hit 0, then go on the positive. So as I sketch this, it's actually going to cross the y-axis because my axis will become negative and then go to positive. That's fine. That's what we're supposed to do. So let's do this, people. So let's that is 1, 2, 3, 4, 5, 6. 1, 0, -1, -2, -3, -4. I'm going to extend this out that way to the left. How come? Because my first dot needs to be at -45. So I will go here is -45. Here is 0. Here's the next one, which is +45. I'm just reading these right here. 0, 45. Then I go to 90. Now I got to go to 135. And let's just place these dots, okay? Let's just place these dots. Okay, this one right here, it's still going to be at 1, but it's going to be at -45. So go to -45 and 1. Okay, this dot here is still going to be at -4 on the y-axis, but it's going to be at 0. So 0, -4. Then I come back up to my midline, 45. I come all the way up to 6. And then I come all the way back down to my midline. So if I were to graph this, oh, I spaced those out a little bit too far, but that's okay. Bam, there you go. It's a great graph. Good for you. I mean, you know, technically I should have moved my 135 here a little bit. This dot probably should have been closer to here to make it more symmetrical, but you know, sometimes poo-poo happens. If you labeled it accordingly and it's a sketch, as long as you have your last dot at 135, you're good to go. Good. Guys are smart. More practice, more practice. We're going to do 2 more. All right? Graph one cycle of y equals -4 sine of 3x minus pi over 4. All right. If you want to pause this and do 3 and 4, go ahead. I'm going to go through it a little quicker. All right? I'm going to rewrite my equation. Y equals -4 sine. I'm going to factor out my 3, and I got x. This is 45 degrees. Divide this by 3, I get my x. I divide this by 3, and I actually get 15. And there's no plus or minus. So my amplitude is 4. It is negative, so it's a vertical flip, and it is sine, so it's going to go down, then up. All right. My frequency is 3. My period would be 360 divided by 3, which is 120. My midline, there's nothing there. So that's still going to be y equals 0. And my left or right movement, this is telling me I'm going to move right 15 degrees. So I'm going to move right 15 degrees. All right? Now I'm going to go without sketching this. Yeah, let's do it for the sake of time. All right? Right now, okay, right now on my graph, if it ends at 120, okay, half of 120 is 60, then it's 30, and then I go to 0, and 30 and 60 is 90. These are the x values for my points. I'm going to add 15 to every single one of those, okay? So 0 and 15 is going to start at 15. 30 and 15, my next one is going to be 45. 60 and 15 would be 75. 90 and 15 would be 105. And 120 and 15 would be 135. These are my x-axis values for the points I'm going to put. Sine, this is where it's going to start. This is where it's going to end. This is going to be the middle. Okay, then here are the high and low points, right? So let's do this. 0. Okay, 0. I'm going up 4 amplitude and down 4. All right, and then I'm going to end at 135. Okay, I'm going to start at 15. In between is 75. And then I have 45 and 105. Right, and it's reverse sine. So it's going to start at 0 at the midline, end at the midline, and in the middle, midline. Since this is negative, it will go down first, then up next. Hallelujah, we're pretty good at what we do. Bam. Last one. Y equals, fraction. This is the same thing as saying 1/2 x, and pi over 4 is 45. Okay? So I'm going to say y equals negative sine. I'm going to take out my 1/2. That leaves me x. 45 divided by a half is not 22.5. I'm not cutting it into 2 halves. I'm dividing it by a half, which means I got to double it. Trust me, kids, it's 90. Amplitude is 1. Frequency is a half. And I am moving to the right 90. My midline is still 0. Stand. So amplitude is 1, but it is negative, and it is sine again. So it's a vertical flip, and it's going to go down, then up. My frequency is 1/2. Ooh. My period is 360 divided by a half. That's actually 720. My midline, that's still y equals 0. And I am moving to the right 90. So right now, I have 720. Half of that's 360. Half of that's 180. And I go to 0. 180 and 360 is 540. I've got to move to the right 90. I've got to add 90 to each one of those x values. So 0 and 90 is 90. 180 and 90 is 270. 360 and 90 is 450. My goodness. 540 and 90 is 630. And 720 and 90 is 810. Woo! Let's graph this bad boy. Okay. So I'm going to go out to 810. I'm starting at 90. Halfway in between them is my 450. And then I got 270. And I've got 630. Ooh, I am moving to the left. Shame on me for going fast. Oh, my goodness. So I got to go to negative 90. I got to subtract 90. It's negative 90. Subtract 90. It's positive 90. Subtract 90. That's 270. Excuse me for making a mistake. Subtract 90. That's 450. And subtract 90. That's 630. All right, so I don't need this one. I'm going to 630. Wow, good catch by me. I'm going to go up to 1, down to negative 1, from 0. Sine starts at the midline, and it ends at the midline, in the middle of the midline. Down low because it's negative, up high, and I go like this. Oh my goodness gracious. I was going fast, and I almost made a mistake, but I did not, and I caught it. I was just trying to finish this. My class is waiting outside for me very patiently because they're good kids. All right, good luck. I'll see you for the next lesson.